pi of 25t times ej 2 pi 300t. Again, the Fourier transform of pi of t is sinc of f, which is sine of pi f over pi f. And so the Fourier of pi of 25t is 1 over absolute of 25 times the Fourier transform of pi of t, where f is replaced by f over 25. So that's sinc of f over 25. X of at is 1 over. And it's also the case that if x of t is multiplied by ej 2 pi at, its Fourier transform is the Fourier transform of x of t shifted to the right by a. So x of f minus a. So the Fourier of x of t is 1 over 25 sinc of f minus 300. F minus 300. The whole thing divided by 25. This is x of f. X of t is 6 delta of at minus 2 minus 5 sine 2 pi 100t. Now this delta is the triangular pulse. Triangular pulse. It's a triangle from minus 1 to 1. It's 0 before minus 1 and after 1, and the height is 1. And we know the Fourier transform of the triangular pulse is sinc square of f, which looks like this. And this is 1. And so the Fourier of delta at is 1 over absolute of 8 sinc square of f over 8. Sinc square of f over 8. Multiply this by 6. You have the right hand side multiplied by 6. 6 delta 8 factor of t minus 2 over 8, that's 1 over 4, is 6 over 8, which is 3 over 4, sinc square of f over 8, times e minus j 2 pi 1 over 4 f, and that's 3 over 4 sinc square of f over 8. E 2 pi over 4 is pi over 2, so that's minus j pi over 2 f. So we found the Fourier transform of 6 delta at minus 2. We now need to work on 5 sine 2 pi 100t. So we have 6 delta at minus 2, so which is Fourier transform into 3 over 4 sinc squared f over 8 e minus j pi over 2 f. And we have 5 sine 2 pi 100t, which is transformed into 5 times the Fourier transform of sine 2 pi at, which we know is 1 over 2j delta f minus a, which is 100, minus 1 over 2j delta f plus 100. And since x of t is the sum of these two signals, its Fourier transform is the sum of these two Fourier transforms. So it's 3 over 4 sinc squared f over 8 e minus j pi over 2f plus 5 over 2j delta f minus 100 minus 5 over 2j delta f plus 100. We have the following signal. X of t is 0 for negative values of t, t between 0 and 1, and 1 for t greater than or equal to 1. We have 0 between 0 and 1. X of t is t. For t greater than or equal to 1, the signal is constant. The derivative of the signal is this. The rectangular pulse shifted to the right, so this is pi of t minus half, because pi of t looks like this, and so pi of t minus half is pi of t shifted to the right by 0.5 unit. Again, this is rec of t or p1 of t. And so the Fourier transform of the derivative d of f, d for derivative, is the Fourier transform of pi of t minus half. Fourier transform of pi of t minus half. Pi of t minus half is sinc of f times e minus j 2 pi half f, which is sinc of f e minus j pi f. This is the Fourier transform of the derivative of x of t. Now let's call this d of f. Okay, now we know x of t is the integral from minus infinity to t x prime of t dt, and so the Fourier of x of t, which is capital X of f, is half d of 0 delta f plus d of f j 2 pi f. Now d of 0 is sinc of 0 e2 minus j pi 0. Sinc of 0 e minus j 2 pi 0. E to the power 0 is 1, sinc of 0 is 1, 1 times 1 is 1, so d of 0 is 1. This is half times 1 delta of f plus d of f, which is this, sinc f e minus j pi f. This is x prime of t, which Fourier is sinc f e minus j